Hello, this is David Shreve, Algebra 2 instructor with Florida Virtual School. We're just going to go through quickly an example of solving a rational equation. So we'll start out with 2/5 plus 3 over 5x equals x plus 5 over 10. So anytime I'm dealing with any rational equation, the first step, I always want to determine my LCD before I really start doing anything. My LCD in this case, at least common denominator and least lowest common multiple, it's sometimes called, they're the same thing. So if we look at the multiples of 5, for example, we would have 5, 10, 15, 20, 25. Multiples of 5x, we have 5x, 10x, 15x, and so forth. So the lowest that they're all going to have in common here is going to be 10x. So once I determine my LCD, that makes it pretty easy for me, because I know I have to have a 10x in the denominator of every one of these before I can start combining them or anything like that. So what we're going to do here, I'm going to first, let me go ahead and rewrite this, and I'm going to put a little bit of space so I can show in detail exactly what I'm doing to each fraction. Alright, so what we have here, and remember I need the denominators to all be this 10x, that LCD. So to make 5 a 10x, I would multiply by 2x. But if I do that to the bottom, I have to also do it to the top. Everything I write is in an equivalent form, so I'm basically just multiplying that by 1, since 2x divided by 2x actually equals 1. So here I've got a 5x, I need it to be 10x. I'm going to multiply top and bottom by 2. Here I've got a 10, so I'm just going to multiply the top and bottom by x. Right. So again, I've multiplied every value here by 1 technically, since x over x is 1, 2 over 2 is 1, 2x over 2x is also 1. Now, from this point, we're just going to perform the operations here. It's just multiplying here. So 5 times 2x on the bottom is going to be 10x. I know that because I wanted to have that 10x on the bottom. On the top here, 2 times 2x, well, that's just 4x. 3 times 2 is 6, and then 5x times 2 is 10x. And then this x here, I'm going to have to distribute it to each term inside. That's going to give me x squared plus 5x. And then 10 times x on the bottom gives me 10x. Now, since I've got the lower portion here all equal at this time, I'm just going to go ahead and on the left here you'll notice I've got common denominator, so I can just combine the top. That just gives me 4x plus 6 over 10x equals x squared plus 5x over 10x. Now, once we get it to this point, I'm really only going to have to focus on the top. Now, I know 10x is equal to 10x, so if these bottom portions are equal, these denominators, that means these top portions must be equal as well. So I really don't have to worry about the denominator anymore to solve for x here. I'm just going to set 4x plus 6 equals x squared plus 5x. So at this point we can see we're going to end up with a quadratic. So I could subtract x squared and subtract 5x from each side, but instead of doing that, I like my coefficient on my x squared to be positive. So I'm going to actually subtract the 4x from each side. and I'm going to subtract 6 from each side. And that's going to, as I said, we're going to end up here with a quadratic. So let's see what we end up with. X squared. Now 5x minus 4x is just x. And then there's nothing here, so 0 minus 6 is negative 6. Now this is our quadratic. We can set that equal to 0 and solve for x, and we'll be done. So remember, when we have quadratics, we can solve quadratics a lot of different ways. I'm going to set the quadratic equal to 0 and solve for x. We can use quadratic formula, completing the square, factoring. This one will actually, you could even graph it in GeoGebra. But this one's pretty easy to factor. It's just x plus 3 times x minus 2 equals 0. So if this quantity times this quantity equals 0, then one or both must equal 0. Set each one equal to 0 and solve for x. So x plus 3 equals 0. You'll just subtract 3 from each side, and x will equal negative 3. X minus 2 equals 0. Just add 2 to each side, and x will equal positive 2. Now, you can think of checking your answer. Just plug these values in. Or you could plug in the value for x, make sure that it works. It's important that we consider the restrictions here. There is a restricted value for x. X cannot be equal to 0. You'll notice my denominator here, 5x. Anytime you see a variable down there in the denominator, just set that term equal to 0 and solve for x. To solve for x here, I would just divide each side by 5. 0 divided by anything is 0. So x cannot equal 0 is a restriction. None of my values here are restricted values. You could still plug them in for the x value and check it if you'd like. Hope this helps.